All right, so, Edward, can you grab those 3 calculators, please?
Oh, perfect.
Yep, we got some calculators for you guys. Okay, today, we're gonna be working on distribution grade 2. This is in Arizona. In Arizona, the exams are ABC certification exams. ADQ is the primacy agency for Arizona, the Arizona Department of Environmental Quality. In every state, they have their own agency, primacy agency. And just a little quick information on that is the Environmental Protection Agency has been empowered by the Safe Drinking Water Act, right, to create and enforce regulations when it comes to water treatment, the potable water in the United States. So each state has the opportunity to enforce those laws, those regulations. And as long as it's, each state can come up with their own laws as long as it meets the minimum federal requirements. So we're gonna go ahead and jump into distribution math, grade 2 math. Now these questions aren't on the exam, but they're very similar. So if you learn how to work through these questions, you shouldn't have any problem with any of the math on your grade 2 exam. Now, so if you, and I have ABC math formula sheets in the same cabinet right there, if you guys want to grab one each. So in this question, a column of water is 675 feet in depth. What is the pressure in PSI at the bottom of the column? When you look at the ABC math formula guide, math formula sheets, you see, those are, there should be 3 of them in there. You'll see these conversion factors. These conversion factors are constants. They don't change. These are facts. And
Thank you, sir. Thank you.
it has information in there that every operator in the water wastewater industry should know. For example, we know there are 7.48 gallons for every cubic foot. Water weighs 8.34 pounds per gallon. These are things that we should know. Now, when it comes to converting the depth of water to PSI, there's 2 conversion factors that we could use. We could use 0.433 PSI per foot, which means 1 foot of water, the pressure at the bottom of water at a depth of 1 foot is going to be 0.433 PSI. Now, if we have 2.31 feet of water in depth, the pressure is going to be 2.31 PSI. Okay, now, I learned a long time ago from a good friend of mine who's an operator in the industry, doing quite well, who's much better at math than I am, to pick one of these and just learn how to use that one. There's a few of these conversion factors that are like that, and the one I chose is 0.433 PSI per foot. You could do this either way, but so when I read the question, a math question, the first thing I do is I just ask myself, what is it specifically they want to know? And they'll tell you, what is the pressure in PSI at the bottom of the column? So using these conversion factors, I'm going to pick one and I'm going to figure that out, right? So I need PSI, right, equals 0.433 PSI per foot. Now, I want to just talk about a couple things real quick because this is the first problem. Whenever I have a numerical value that's less than 1, I always write 0.433, and that comes from my mentor in this industry. Years and years ago, he told me as we were doing labs in a wastewater treatment plant, when you have a value less than 1, put that 0 there. All your coworkers everyone that sees your paperwork will get used to seeing that, hey, this is a value less than 1. Just simplifies things. We did have operators that didn't use that 0, and I don't think we ever ran into any major problems over it, but there were times where people thought, is this a point? Is this less than 1 or whatever? I always write down the unit of measure. Anyone who watches these videos, who interacts with me, knows that when I'm doing math, I try to follow the same steps every time, even if it's very simple, especially when I'm taking exams. Because units of measure is what helps me have confidence that I'm solving the problem correctly and getting the correct answer. So I'd love to cross cancel. Now, we know that in this conversion factor 0.33 psi per foot, the question is telling us that the water column is 675 feet in depth, right? So what I'm going to do is, let's say I wanted to divide, and this is going to be incorrect, but it's just an example. If I wanted to divide 675 feet in depth, I would write it like this: 675 feet over 1. To cross cancel this, I would want to have that foot below this division line. So this is a division line, this is a division line. If I wanted to cross cancel this, I can't. I can't get rid of the feet, and I'm looking for PSI. So I'm going to erase this, and I'm going to write the equation as multiplication. The depth is 675 feet. Feet over 1 is the same thing as feet. Okay? So now you see what we've done here is now we have PSI over foot. Foot is below the division line. Over here, it's foot over 1. Foot is above the division line. So I can cross cancel foot, foot, and I'm left with PSI, which is the unit of measure I'm looking for. So now I have confidence that if I multiply 0.433 times 675,
292.
I'm going to get 292 PSI. That's a very simple example of the steps I go through to solve a problem. You identify either the formula or the conversion factors that you're going to use. You write out the formula, cross cancel, and then solve. All right, question number 2. A pressure gauge at the bottom of the storage tank reads 50 psi. What is the water level in feet? So here we have the conversion factors that are on the ABC math formula sheet. 0.433 psi per foot, or 2.31 feet per psi. What this means is for every foot of water depth, you have 0.433 psi. If you have 2.31 feet of water in depth, it equals 1 psi. Now, my favorite conversion factor to use is 0.433 psi. I'm looking for, and here's my first question to myself, what is the water level in feet? That's specifically what they want to know. That's the answer we're looking for. So I want depth in feet. That's my unit of measure. So if I look at this, I'm going to see that 50 psi. We can rewrite that as 50 psi over 1. 50 PSI over 1 is the same thing as 50 PSI. It's just that we're adding a division line. So when I look at my conversion factor, 0.433 PSI over feet, I realize that the unit of measure feet that the answer is going to be in, PSI needs to be eliminated. Here, PSI is over the division line, and here, PSI is over the division line. That means I need to divide. So I'm going to take 50 PSI over 1, and I'm going to divide it by, and I put it in parentheses, and it's a habit I have. It's not wrong, it's just, sometimes I do that. Just so everybody knows. Going through an elementary school, high school, all that, I was never a very good math student at all. When it comes to the water wastewater industry math, I'm much more comfortable. Sometimes I stumble, but I catch myself, and the reason I do is because I follow the same steps every time. I try to follow the very same steps every time. That is, read the question, understand what it's asking you, look for your formula or the conversion factors, write it down, and then rewrite the formula with all the information from the question in, and then cross cancel. So we're at the step now where we're going to cross cancel. I can take this PSI and I can cancel it out because it's over the division line. I have a division line here with this unit of measure. PSI is over the division line here. That means I can cross cancel these out. I'm left with feet, which is the unit of measure that I'm looking for. Now it comes down to doing the math. 50 divided by 0.433 gives me 115.47 feet. Now, these are multiple choice questions. You might get 115 feet as one of the choices. You might get 106 or 116. 115 and 116, you would round. You would round to get the correct answer. Now, if I had taken my conversion factor, 0.433 PSI per foot, and divided it by 50, I would have gotten something 0.0008, which is a mistake that I've made before.
Yeah.
And it just doesn't make sense. And because we're writing this down, because we're following these steps, we can go back, retrace our steps, and determine where did I make the mistake. So in this case, we're doing 50 PSI over 1 divided by 0.433 PSI per foot gives us 115.47, which is the correct answer. Okay, the next question. A water main has been scheduled to be upsized from 8-inch diameter PVC C900 to 12-inch diameter PVC C900. The section of main is 330 feet in length. PVC C900 pipe is available in 18-foot lengths or sticks. How many sticks or pipe are required for the project? Now there's a couple things I want to point out here. Number one, 8-inch diameter. So, and it's PVC C900. This is a type of, this PVC pipe is a type of pipe that is commonly used, especially in the system we work in, for water mains and force mains. It has a pretty nice pressure rating, and we have confidence that as long as it's built correctly, it's gonna hold together just fine. We won't have any problems. So we're gonna increase this water main from 8-inch diameter to 12-inch. What that means is the pipe is round. If you're looking at it as if you're looking through a telescope or a straw, this pipe is 8 inches in diameter. Diameter is from one side to the other. And we're increasing it from 8-inch to 12-inch. A little bit larger. That's going to give us a lot more volume. a lot more volume to move more water with less friction loss. Friction loss is, even though you're sending water through a pipe, because it's constrained within the pipe and the pipe is completely full, and there are several other factors that go along with this too, there is back pressure. Is the friction of the water moving through the pipe that's going to give you back pressure. Now, if you have a 45-degree bend or a 90-degree bend in the pipe, that's going to add more friction loss. If you are, and so that's what we're trying to do here, is we're trying to send more water downstream. We'll be able to send more water downstream if we have more volume. Okay. Now, those of us who've worked in the industry a while know that PVC pipe comes in 20-foot lengths or sticks. In the industry, we call it sticks, right? When you're working out in the field, all our contractors, we all know that it comes in 20-foot lengths. We call them sticks. In this question, it's asking for 18. It's for some reason, the pipe is only available in 18-foot sticks. So it's a test. It's a test to figure out if you can, to determine if you can figure this out. So now what is the formula that I'm going to use here? Well, it's how many sticks of pipe are required for the project. So I'm going to write down sticks. Now, the length of this pipeline is 330 feet. So I'm going to write down length 330 feet over 1. When I write down 330 feet over 1, it's the same thing as 330 feet. Thank you, Edward. I guess the motion sensors in this room aren't working.
No.
That's all right. So we also know that each stick of pipe is 18 feet in length. And I'm going to write that down as 18 feet per stick. So when I write that down, this unit of measure, 18 feet over stick, I notice that feet here is over 1. So, and my unit of measure is in sticks. So I need to get rid of the feet. So I'm left with stick. I'm going to do that by dividing. (18 feet) over stick. You see what I did there? So now, because foot is above the division line here, there's a division line, and then foot is above the division line here. Now I can cross cancel and get rid of the feet unit of measure. Take that one out, take that one out. I'm left with stick, and that is the unit of measure I'm looking for. All right, so let's take 300, divide that by 18-foot sticks, and we're gonna get 16.66 sticks. Now, 330 divided by 18, did I do 300? Let's see if I made a mistake. 330 divided by 18 equals 18.33, excuse me. Yeah, I put thanks for catching that. 18.33 sticks. Now, as we've said, we can purchase these sticks in 18-foot lengths. Can I purchase 18.33 sticks? No. I'm gonna have to convert that to 19 sticks. 19 sticks would be the correct answer. Now, whenever you're taking an exam, be very careful that you read exactly and understand exactly what they're asking you for. Because in this case, it says how many sticks of pipe are required for the project. And because we understood that, we were able to figure out that, hey, we're gonna have to buy 19 sticks of 18-foot lengths of 12-inch diameter PVC C900 pipe. That question might be, how many feet of pipe? Just be very, very careful you're identifying what the question is. What is it exactly that they want to know from you?
So when it asks us for surface area,
No, it's okay.
when it asks us for surface area, are we still using, like, were we using the sense of a diameter of the area?
We're going to, not diameter so much as circumference. So let's just start with the question real quick. Calculate the surface area in square feet for the inside of a cylindrical ground storage tank scheduled to be coated for corrosion control, which is 68 feet in diameter and 22 feet in height. Include the sidewall, floor, and roof. So we have a ground storage tank. We have one right out here in the office, right? We've all seen them. They could be short and large in diameter. They could be taller and less in diameter. They could be tall and have a great large diameter. I mean, they come in all shapes, all sizes. But typically these ground storage tanks are cylindrical, okay? So now this one is 68 feet in diameter. Diameter is, if I take a circle, I have if I go from one side to the other, this is the diameter. If I go from the middle to one side, we call this the radius. But if I start at one point and go all the way around and match up to that point again, I have the circumference. Now it's important to know, and I think we all know this, pi, and that's the symbol for pi, is 3.14. And there's a lot of other numbers as well, but it's basically 3.14. So to coat the inside of the tank, we want the surface area of the sidewall, which goes all the way around, that's the circumference. We want the surface area of the inside of the roof and the surface area of the inside floor. So we're gonna have to get all those factors. We're gonna have to calculate the area in square footage to determine what the total area is. So let's start with the sidewall. And I'm going to write area in square feet, and I'm just going to write sidewall. Now, when you look at your ABC math formula sheet, and this is what it looks like when you print it out. Formula conversion guide, ABC. It's available on the ABC website. It's available on my website when you click on the free download button. What we're going to look for is circumference of a circle. circumference of a circle is 3.14, which is pi. 3.14 times the diameter. And they don't give you the unit of measure for the diameter in the formula. Because it might be inches, it might be meters, it might be feet, it might be miles, it might be whatever. They don't know what question you're trying to answer, is what I mean. So what I'm gonna do is I'm gonna rewrite this using the information that I have available to me in the question. And the formula is 3.14 times diameter. And we can see that the diameter is 68 feet in diameter. And I'm gonna write that as 68 feet over 1. Why doesn't that seem right?
It's supposed to be squared, right?
Yeah. Did I read that wrong?
Yeah.
Oh, I'm looking for circumference of the circle. I'm looking for the length, and I want it in feet. So what I did wrong here is I assumed it was gonna be in square feet. It's gonna be in feet.
Mhm.
Because this unit of measure is in feet.
Yeah.
And if you look at your formula, 3.14 times the diameter of 68 feet over 1, I'm gonna be left with the unit of measure that I'm looking for. There's no cross canceling. I'm looking for feet. I'm gonna get feet. So let's go ahead and multiply 3.14 times 68 feet. And that's gonna give me 213.52.
Now, when you say sidewalls, that's considering feet, correct?
Yeah.
So you're.
That is going from one point all the way around the circumference and matching up to that point again. So what I'm doing here is I've got the ground storage tank, right? Kind of looks like that. I don't know why I can't draw today. So what I did was I measured from that point all the way around to here.
Correct, but you put sidewall. Sidewall would be considered the walls, right?
Yep, I'm almost there. I'm catching up to you. So what if I took this sidewall and I cut a line right through here? Let's say I had a big saw and I went up to the 68-foot diameter tank and I cut a line right down the center. And then I took that sidewall and I laid it out flat on the ground. Now I know it's 22 feet in height. So this dimension is going to be 22 feet. This dimension, the height is going to be 22 feet. By using this formula, 3.14 times the diameter, what I found is that if I start at one point and go all the way around, or if I cut it down the side and lay it out flat, the length is going to be 213.52 feet. Does that make sense? Okay. So now I've got the length, 213.52 feet, and the width, or in this case, height. We can call width height. Let's just call it width so I don't have to erase it, 22 feet. So now, if I want area in square feet of the sidewall equals the length, 213, and it's right in front of my face, feet over 1, times height, which is 22 feet over 1. Let's cross cancel. I have feet over the division line here, feet over the division line here. Well, I can't cancel those. They're both over the division line. So now I gotta count them. Because I'm multiplying, I've gotta say, this is 1, this is 2, which is the unit of measure I'm looking for. So now let's multiply that out. 213.52 times 22 gives me 4,697. And we'll just call it that. Square feet. Feet times feet equals square feet. My answer is going to be in square footage. We're not done yet though, right? We need area in square feet of the roof, which is going to be the same as the floor. So the roof and the floor, they're both the same. This is the roof, and the floor is down there. So we need the surface area of both of those. How are we going to do that? Well, this is a cylinder, a circular object, right? So I need area of a circle. I don't need the whole cylinder, I just need area of the circle. So if I look on my ABC math formula conversion table, I'm going to see area of a circle, and you get a couple of different options. You can use 0.785 as your conversion factor times the diameter times the diameter, or you could use pi, 3.14 times the radius times the radius. Either way is going to be correct. If you know me, then you know that because of some advice I got from one of my best friends is to pick one and use that one so you're comfortable with it all the time. And because I'm not a genius, because I'm not the greatest math student in the world, I picked 0.785. That's the one that I use whenever I'm doing calculations that involve circles and cylinders or cones. 0.785. So my formula is 0.785 times the diameter, which is 68 feet. And I write that 68 feet over 1. And then we're going to multiply it by the diameter again. 68 feet over 1. Now, if I multiply this out, I'm going to get the square footage of the floor or the roof, right? But if I multiply this by 2, I'm gonna get both of them at the same time. Can I cross cancel anything out? I've got foot over the division line here, foot over the division line here.
No.
So there's one of them, there's another one. I'm looking for square feet. Nothing to cross cancel. I'm gonna take 0.785 times 68 times 68 times 2 of these things. And I'm going to get 7,260. All right. So half of that is going to be 3,500, 3,710 square feet. So if I didn't multiply by 2, I'd have 3,710 square feet. I multiplied by 2 because there's a roof and there's a floor. Make sense?
Makes sense.
All right, cool. Now let's see what I got here. So first thing I did was I calculated the length of the sidewall in feet. And you know what, I should have done this correctly, I should have written it just like this, cause I wrote down area. It should have been length in feet. Can't believe you guys didn't catch that. Especially you.
I was confusing, I was like, oh.
See, and that's the thing, if you're confused, man, say I'm confused. I want everybody watching this video to feel confident in it, like, hey man, yeah, this guy isn't perfect, but he knows his stuff. And if you follow this step by step by step, you're gonna come up with numbers that you feel good about, okay? So, what I'm gonna do is say, first thing we did is we determined the length of the sidewall. If we cut this sidewall right straight down from top to bottom and laid it out flat, it gave us the length. We already had the height. We multiplied length times width to get the area of this wall. And then to get the area of the roof and the floor, we use this formula to get this number. So if I take 4,697 square feet, and I add that to 7,260 square feet. Did you add it together?
Yeah. 11,956. I'm sorry. 957. It gave me a point in there.
Okay, 11,957 square feet. Okay, this problem goes on to say, if the tank requires 2 coats and one 5-gallon bucket covers 600 square feet, how many buckets of paint must be purchased? Now, previously, we calculated the sidewall square footage, the roof and the floor combined square footage. We added that together for a total area of 11,957 square feet. Okay? So, we know that we have area 11,957 square feet over 1. And we know that one bucket, one 5-gallon bucket covers 600 square feet. 600 square feet can be written as 600 square feet over 1. Square foot is above the division line here. Square foot is above the division line here, which means I'm going to have to divide if I want to cross cancel and get the square footage out, because I want buckets. So, and in fact, I could do 600 square foot over bucket. Because one 5-gallon bucket, 600 square feet. Does that make sense?
Yeah. Makes sense.
All right, so I'm going to divide 600 square feet over bucket. So I'm looking for 5-gallon buckets. We know that one 5-gallon bucket covers 600 square feet. We know our total area, 11,957 square feet. I could cross cancel out square footage here, and I'm left with buckets. So let's take that 11,957, divide that by 600, and that's going to give me 19.9. Does everybody agree with that?
But it's gonna be 2 coats, right?
With 1 coat.
Yep. 19.9 buckets. But we want 2 coats. 19.9
By 2
times 2.
39.85.
Okay. So what could I have done here in this formula? I know the area,
Twice.
yeah, we could have multiplied it by 2,
Yeah, double up.
right? But instead, I'm taking 19.9 buckets. And that's per coat. Times 2 coats over 1. So I can take out coat here, I'm left with buckets. And the answer is gonna be, and I'll write it in this color, 39.85 buckets, which I can round up to 40 buckets. Cause you can't buy less than 1 bucket, right?
Correct.
Sure.
25.
Okay,
Makes sense.
does that make sense? Everybody's happy with that?
Yes, sir.
Very good.
Sweet.
I'm not as smart as I look, for sure. Okay, the next question, calculate the volume of a trench. 363 feet in length, 3.5 feet in width, and 6 feet in depth. Now, if you look at your ABC math formula sheet, you're gonna see volume of a rectangular tank. Now, there's an asterisk by it. We can call this a tank. We know this is if we had a rectangular tank with the same dimensions, it would look very much the same. The volume would be the same, depending on what the unit measure we're going for. So we're gonna call it a rectangular trench equals length times width times height or depth. That's our formula. It has no units of measure, so we're gonna rewrite this, plugging in the information that the question gives us, right? So I want volume, and this volume is going to be in cubic feet. I know that because of the question. Well, the answers, the 4 choices are cubic feet. If it was square footage, we could eliminate those right away. The problem would be, is if they said, what if it was in gallons, right?
Mm-hmm.
So the question says nothing about what unit of measure they're looking for. So we would have to solve this for cubic feet and for gallons because of the choices that are available. We want the most correct answer, and that's one of the qualifiers for every one of these 100 questions on your multiple choice exam, no matter which exam you're taking. The first rule is always answer, or the correct answer is the most correct answer that you can select from, right? So we want volume, and because I'm looking at the units of measure available in the choices, it's cubic feet equals the length, and the length of the trench is 360 feet over 1. We've got width. The width of the trench is 3.5 feet. And the depth is 6 feet over 1. One quick check, 363, 3.5, 6 feet. That's my formula, looking for cubic feet. Cross cancel. I'm multiplying straight across. All the units of measure in feet over 1. That means foot over 1 is above the division line for all 3. That's 1 of them, 2 of them, 3 of them, I'm looking for cubic feet. It looks like if I multiply all this together, I should get the correct answer. 363 times 3.5 times 6 equals 7,623 cubic feet. Does everybody agree with that?
Yep.
And by the way, the calculator I'm using, and this is the rules in Arizona, I'm sure it's the same everywhere else. It's just a simple solar powered calculator. It costs like $5 at Walmart. That you can't program it. I know where we go to take our exams, we can take ours in, or they provide it for us. As long as it's a very simple calculator that you can't program anything into. Okay. Now the next question asks, what is the volume in cubic yards? What is the volume? In cubic yards. For the same question. So what's a cubic yard? Well, what's a cubic foot? If I had a cube that was 1 foot in length,
1 foot.
by 1 foot in width, by 1 foot in height, I would have 1 square cube, right? Or 1 square foot, excuse me. So I would have 1 cubic foot. Let's say it correctly, 1 cubic foot. Length times width times height, 1 by 1 by 1, 1 cubic foot.
Foot
Sorry.
cubed.
I'm trying to get ahead of myself in my brain, and I'm messing everything up. So what is a cubic yard? What's the length of a yard?
So that's 3 feet, 4 yard.
So what would be the width?
So it'd be 3 feet by 3 feet by 3 feet.
3 feet by 3 feet by 3 feet. So if I take 3 feet times 3 feet, I'm gonna get 9 square feet. If I add the depth, 3 feet,
You get
then I'm gonna get 27 cubic feet. So 1 cubic yard equals 27 cubic feet. Do we agree with that?
Yes.
Okay. So I know that I have, and what I'm trying to solve for is, what is the volume in cubic yards equals, I have volume $7,623 cubic feet over 1. And I know that a cubic yard equals 27 cubic feet. How do I write that down in a unit of measure? Do I do multiplication? 27, excuse me.
You get the yards, wouldn't you have to divide on that?
I just had a brain fart. And as everybody knows, and anybody watching my videos knows, I'm not the greatest math student, but I can figure this out. So I'm gonna write down cubic yard 27 feet cubed. Nope. 27 let's write it down like that. 27 cubic feet per cubic yard. Does that make sense?
That was a lot better.
All right, let's cross cancel. I have a cubic foot over the division line here. I have another division line, which means I can cross cancel out this cubic foot. And I'm left with cubic yards. That's the unit of measure I'm looking for. You see, I practiced this last night, and my brain still just now tripped up on me.
Mm-hmm.
But if you work through the problem, you can figure out, hey, wait a minute. How do I fix the units of measure to cross cancel out what I don't need? And that's what I had to do. My brain went here for some reason. And I think to a lot of other people, when they saw me do this, they said, what is this guy doing? What's he thinking?
Well, I see what you're doing there.
But now I went back and said, wait a minute, I've got 27 cubic feet per cubic yard.
Yep.
So let's see what the answer is. 7,623 divided by 27 gives me 282.
0.3.
.33 cubic yards. That's the unit of measure.
Yes.
And we need to know this because maybe that spoil, the dirt that we took out of the trench, maybe it's going away and being replaced with something else. So when a contractor or us as a utility is trying to calculate how many trucks are we going to need to haul off the spoil, the dirt that came out of the trench, well, let's say I got a truck that can only haul 250 cubic yards and I don't have any other trucks available. Well, now I know it's going to take 2 trips to do it because I have 282.33 cubic yards. Maybe it's a situation where I have to take every bit of that dirt away. It can't stay at the site. Because on some sites you can just say, don't even haul it away, just level it out over the ground that's already there. Especially when it's a small amount. But in this case, I gotta truck it all the way. My truck only carries 250 cubic yards safely. So I'm gonna need 2 truckloads. Might as well just divide it in half and take a half a load at a time, or maybe a little bit more than half, and call it good. Okay, the next question. If the desired dose for chlorine is 2 milligrams per liter, how many pounds of chlorine per day will be needed to treat 2.1 MGD? There's a few things in here that every operator in this industry needs to know. First of all, milligram per liter is the same thing as 1 part per million, ppm. For years and years, that was one of the questions on your grade 1s exams. Sometimes you found them on grade 3s and grade 4s even. 1 milligram per liter is the same thing as 1 part per million. I also want to bring up MGD. Million gallons per day. That's what MGD stands for. This is how we rate the capacity of a water treatment plant or a wastewater treatment plant. And in this plant, or in this scenario, we're treating 2.1 MGD, or 2,100,000 gallons of water. How do I know that? Well, if I take 2.1 and I multiply it by a million, which is also an M, million, I'm going to get 2,100,000. If I take 2,100,000 and divide it by 1 million, I'm going to get 2.1. Okay? These are just things that every operator should know. So, the desired dose for chlorine is 2 milligrams per liter. How many pounds of chlorine per day will be needed to treat 2.1 mgd? I'm gonna go to my math formula conversion table, my ABC formula conversions. Go to almost the last page, the very last page. And on here, you're gonna see a bunch of diagrams of pies. We call these pie wheels. And the one we're looking for is feed rate. It's a second row down, right in the middle, feed rate. And essentially, this is what it is. Draw a circle. We're gonna call that a pie. We're gonna cut that pie in half. That line in half is what we call the division line. So what I'm drawing here is a math formula in the form of a pie. Here, I'm gonna cut the bottom half of the pie, I'm gonna cut it into thirds. Right? So what I'm doing here is anything below the division line is going to be multiplied together. This times this times this. Now each section of this pie has its own units of measure. So the top piece, the top half, is what we call feed. And it is always measured in pounds per day. The first piece of the lower half of the pie is going to be flow, and the unit of measure is million gallons per day. The middle piece is dose, and that is in parts per million or milligrams per liter, okay? Because I'm dosing a chemical. That's the amount of the dose. Now I also have a constant. Earlier we talked about constants that every operator should know. And one of those constants is that 1 gallon of water weighs 8.34 pounds. This pie, this piece of the pie is always going to be the same. It's never going to change. The name, the designation, and the units of measure for each of these are never going to change. But what's going to change is the factor, or what we put in there, right? So, in this problem, I have the desired dose is 2 milligrams per liter. And for this example, we're just going to write it 2.0. How many pounds of chlorine per day, that's pounds per day, will be needed to treat 2.1 mgd? See how I wrote it right here under the flow? That's the flow. We've got the dose. We've got 8.34 pounds. So if I multiply these across, 2.1 times 2 times 8.34, I am left with 35 pounds per day. It goes right there. It was 35.028. I'm just going to round it to 35. That's good. Everybody agree with that?
Yep.
Yes, sir. All right. I see a bunch of nodding heads here. I like that. Next question is, what is the chlorine dosage in milligrams per liter if 4.6 mgd is treated with 55 pounds per day of chlorine? We're going to use the same pie formula that we used in the previous question. I'm just going to draw it a little bit differently. Instead of drawing the circle, I'm just going to go, here's my pieces of pie. Feed, pounds per day. Flow, in million gallons per day. Dose, in milligrams per liter. And my constant, 38.34 pounds per gallon. So let's fill in the information we need. What is the chlorine dosage? We're gonna look for dose in milligrams per liter. If 4.6 mgd is treated with 55 pounds per day of chlorine. So what I'm gonna do is take that information, I'm gonna do 55 divided by 4.6 times 8.34. Who just did the calculation?
You get 1.43.
1.43?
Wait,
No, what's 4.6 times 8.34? That's what I'm asking for.
Oh, I'm sorry.
38.364.
I'm jumping way.
38.364. Okay, that makes a lot more sense. I know what you did.
I was jumping ahead.
You've already done that part,
Yeah.
right? You already took 55 and divided it by 38.364.
Yeah.
And what did you get, Edward?
That one I got 1.43 or 1.4. I rounded it up.
Yeah.
1.4 milligrams per liter. 1.43, you rounded it down to 1.4. Either one is correct. Right?
That's right. I was jumping ahead.
Follow the steps.
Yeah.
Stay with me, man.
That was.
You're always going off ahead of me.
Pump brakes, turbo.
That's my lead operator, Brian. He's a jerk. If you saw his beard, you wouldn't be able to take him serious.
We don't have to show that.
Guess we'll see.
How many pounds per day of liquid alum are used if the flow rate is 12.7 million gallons per day and the dosage is 8.25 milligrams per liter? The purity of the alum is 48%. So we're going to start with the pie wheel. Go ahead and stop it. Okay. We got a call. So I'm the on-call foreman this weekend. And that call came to me. We're gonna look at that here in a little bit, but for now, we're gonna start with the same formula. Okay, how many pounds per day of liquid alum are used? If the flow rate is 12.7 milligrams per liter and the dosage is 8.25 milligrams per liter. So just like before, I have these three factors across the bottom. We multiply them across. 12.7 times 8.25 times 8.34, and that gives me 873.82. I'm going to call it 874. 874 pounds per day. Now, thing to consider here is that the alum is 48%. I know that pure alum, and this is what this formula does. It tells me it's basically assuming this is 100% purity. So if I, like the previous problem was chlorine, that was the pounds per day if it was 100% pure chlorine gas. But normally at our plants we use sodium hypochlorite. Sodium hypochlorite is the bleach or the liquid form of chlorine. And we get it in concentrations or purity about 11-12%. When it's manufactured, the purity is much higher. like maybe 14 to 15%. Once they manufacture it, they put it in storage tanks. Moving the chlorine degrades it a little bit. And they put them in these 300 to 500 gallon totes. They put those totes on trucks. And then they truck them out here to us and they offload them with a forklift, right? So the transportation, moving that chlorine around inside that container, the sunlight and the heat hitting the container. This is Arizona. We just went through recently 31 consecutive days of 110 plus degree temperatures. And this stuff is outside. The heat, the sunlight jostling it around degrades the chlorine a bit. By the time we go to use it, it's 10, 10 and a half, 11, if we're lucky, 12% available chlorine that's in the sodium hypochlorite. So of the 300 gallon tote, let's say 11% of it is chlorine. The actual chlorine, everything else is what carries, it's the vehicle that carries or delivers that chlorine to the water we're trying to treat, right? So we know that at 100% purity, the alum, and in this case it's alum, doesn't matter what it is. What matters is that we know that the purity is 48%. What I'm gonna do is I'm gonna take that 874 and I'm gonna divide it by 48%. Divided by, and to divide it by 48%, you have to convert to a decimal. 48% of 100, is 48, right? So if I liken it to a dollar, if I have a dollar, 48 cents is 48% of that dollar. And how do I write 48 cents in a decimal? 0.48. So if I take 874 and divide it by 48, I'm gonna get, 874
You're
divided by
gonna multiply it.
0.48. Oop, shit. Yeah, if I change it to a decimal, I'm gonna multiply it, right?
Just change it to the
Yeah.
decimal. So. Maybe 870. Well, the way I do it is usually 874 times 0.48.
Yeah, 874 times 48. I can do this a couple of different ways. If I take 874 and divide it by 48%, I get 1820.8 pounds per day. If I take 874 and I multiply it by 0.48, I'm gonna get 419.
419.
Yeah, first way.
Oh,
the
that's-
right way to do it.
Yeah,
Your right way is the times on it by the 0.48
is multiplying it by 48, by
because
0.48.
your purity for the alum is the 48%.
Does it? Yeah, yeah. Well, think about it though. If the purity is only 48%, less than half,
Mhm.
yeah, I'm gonna have to dose a lot more. Right? Because that's not 100% pure.
So realistically, if it's almost half, you could just times that feed by pounds by double.
Yeah, 874 and 874 is 1700 and something.
1744.
So you take 874, divide it by 48%. If you put those keys in,
I'm confused.
874 divided by 48% is 1820.8.
So you're trying to
Are
achieve the percentage of it to be 100%?
Correct.
Yeah, because we
Okay.
want, the purity is 48%.
Yeah.
So we need to know, because the alum is in a liquid form, right?
48%. So typically this is be from purity matters.
Alright.
Because we're dealing with 48% impurity, roughly you're looking at like 50%. So if you take that number that we have as the 874, and if that is half of the purity.
But it says at
100%.
the beginning of it, how many pounds per day
Yeah, well-
of liquid alum are used in the flow rate of
So
everything
if
you
you
got
take
going on?
874,
Yeah, that's based on, if it's
I know
100%.
what you're doing, but I'm trying.
But
to
it's signifying
why
the
you're
purity
doing it
is
that way.
48%.
Like because.
Because like for instance.
So it's just like
So if
sodium
you're-
hypochlorite.
Oh, okay, I see what you're saying. So,
No, this is just a quick
okay,
way.
so this is what you're saying. So if this is.
If sodium hypochlorite was 100% pure chlorine, then
And you're trying to get 100.
using this would work.
Mhm.
But because it's only, let's say 11%,
Pounds.
then you'd have to divide it by 11%, which would give you
Your X
how much of that
That's 40.
liquid bleach you would need to dose
Let's just say.
to achieve
So if I tell you, okay,
the amount of
our
chemical
feed
you
rate-
want to
our
put into
chemical
the
feed
flow.
is 874.
And that's what we're doing
You gotta
here,
have
is
the purity at 100.
to get 874 pounds
How much you-
of
you-
alum
you-
So
into
let's
the
just
water.
say 0.48 is 870.
You need-
That's what it is, right?
1,820.8 pounds
874.
of liquid
Trying to find out
alum
what I had. Okay, 874 is 48.
to achieve this.
So
Gotcha.
let's just say, I'm just doing this whole thing to make it
Whatever works for you.
0.02, so that's 17.4.
It just confuses me a
So,
little bit. Just,
plus-
I think
Because
it's just
if I,
like the
if I
percentage.
multiply this by
Technically, this would be
0.48, I'm gonna, my answer's gonna be less than half of that.
50%
That's not what I'm trying to do.
That'd be 50%.
times 2.
I know that
Yep.
the liquid alum is only 48% alum.
Yeah,
It's 52% whatever carries that alum in the container I bought
See,
it in,
that's.
Yeah.
right? So
I wanna do the.
if I have 1,000 gallons of liquid alum, 48% of it is actual alum. The other stuff that it's
Well,
with
because-
doesn't do anything to treat
Yeah.
the
So
water.
we got the feed
It's
rate,
just
which was
what carries the alum
Oh, that is telling.
to the water I'm trying to treat.
Yeah.
Divided by 48.
Okay, that makes sense.
So
So
1820.
Is that start, that's making
Yeah.
sense now, right?
1820. Okay, if
Yeah,
this
so
happens,
when it
then-
gives us the purity,
Okay, yeah, now I get it, yeah.
Good job.
then 48%, now we have to divide it by
So we didn't do
48%.
times it by 48%, you're actually calculating 48%. And then from there. That confused the crap out of me.
Let me think of it this way. Let's say I've got liquid alum, right? I had it delivered to me in a container. Let's say it's 1,000 gallons of liquid alum. Only 48% of that liquid is actually alum. There's 52% of it is water and other chemicals. That is how we deliver the alum to the water that we're treating. So it doesn't do anything to treat the water. The only thing in that liquid 1,000 gallons of liquid alum that treats the water is the alum itself. And there's only 48% of it is alum. So if I multiply 874 times 0.48, I'm gonna get less than half of this, and that's not what I want. If I multiply it times 0.48, I'm getting 48% of this.
Yeah, you're getting 40%.
But what I need is 874 pounds per day of pure alum.
That's to
so
get your
the-
48%.
So if I divide it by 48%, then what that's giving me is how many pounds per day of the liquid alum that I need to have on hand.
So your 1820 is your 100%.
No. Well, yeah,
Yes.
well, hold on. The 100% is the 874.
Well, see, the way I'm looking at it is, you calculated, so the way I'm looking at it is, when you're calculating 874, like, let's just say, when you're calculating 874, to me, you're telling me that you're giving, that 874, you're telling me that that's your 48% of something.
Nope.
Because look, think about it. If you do 1820 and what's 48% of 1820? 874, right? Because you
Yeah.
just did it, but you did it backwards.
Well, yeah, well, that's a good, wait, you're there. Okay. This is 100% purity. That 874 pounds is 100% pure.
But when you calculate the 48%,
Go talk to him real quick, please.
the way when you calculated the 48%.
Whoa. Forget 48%.
Okay.
Forget 48%. How much alum am I gonna need to treat this flow at this dose? I need 874 pounds of pure alum.
Okay, but see, if you're doing it like this, now I'm going back to the way I did it before, which if that's how much you need at 100%, 874 pounds per day at 100%, okay, so it's saying the purity is 48%, but you've just calculated.
Just follow this with me. Just
Okay.
let's get right here
Okay.
first. So this formula is assuming that the chemical that you're dosing is 100% pure. In this case, it happens to be alum.
Okay.
Forget all of this.
Okay.
Forget the purity. If I have 12.7 million gallons per day, and I'm dosing it with 8.25 milligrams per liter, times 8.34 pounds, the amount of 100% pure chemical I need is 874 pounds.
Right. That's
Now-
assuming that it's
now-
100%.
That's at 100%. If
Right.
it was just pure liquid alum, and I'm dosing the flow, it would be 874 pounds. However, I can't get alum in 100% purity. I can get it in 48% purity. Okay? So what I need to do is take that 874 pounds per day, and I'm going to divide it by the purity of 48%. So I know, because it's less than half, it's just under half, I know it's going to be almost double, right? Just in my head, I know that if my liquid alum is 48% alum, and I have to deliver 874 pounds of it, then the amount of liquid alum I have to dose is going to be more than twice the 874 pounds. We're looking at least 1,700 pounds. So when I divide 874 by 48 and you hit the percent sign,
74 times 48%.
874 divided by 48%,
What'd you get?
1820.8.
Yeah. Divided by 48%. You're hitting times or divide? You got sausage
I'm probably hitting times.
Yeah, got sausage fingers like me.
Yeah. Short was the, okay, so
Here, hit all player again. That way you know. So 874 divided by the 48%, because that's all you can be shifted. Then that's where you get the 1820. I think you're.
yeah, I
you
was
kept it
overthinking
times
it. So I was, especially using this percent, is that your green back truck?
Okay, what we were just talking about is, how our minds work when it comes to math. And like I was saying before, I was never the best math student, It's so funny because when I was 10 years old, my dad took me down to the local bank and opened a checking account for me. I had my own checking account at 10 years old. And he sat with me, and this is back in the old days when you had a checkbook and a check register. And you had to go through, every month you got a statement from the bank, and you would have to balance your checkbook with the bank to make sure everything was correct. You had to account for checks you had written but hadn't been cashed yet. Right? So, and there's a method of doing all that. And I learned, it took a couple of months, but my dad very patiently taught me how to do that. I can grasp that. I never had a problem with addition, subtraction, multiplication, division. It was when I got into pre-algebra. I get into pre-algebra, they start talking about exponents and different things, and I really struggled with all that. because my mind just doesn't work that way. Fortunately, I was able to make it through high school and get all the credits I needed to graduate, but it was close. The only problem I had was math. Everything else, it just graded. So yeah, we tend to, when you struggle with math, you tend to overthink things, and you tend to, I know my brain, the way it works is when it comes to multiplying a decimal is understanding what that means. If I'm multiplying 100 times 0.48, well, that's 48% of the 100. But if I take that 100 and divide it by 48%, now I'm more than doubling it, right?
Yeah, exactly what happened. You just you're calculating what you need and not what. Yeah.
And even explaining it, even though you're starting to get it in your head,
It's still hard to put it in words.
It's hard
but
to put
I
it
see
into
it in
words.
my head now. But
Yeah.
it's hard to put it like.
yeah, because you know, the good thing about this though, is that we can put it into terms that we can understand,
Mm-hmm.
because we know what a 300-gallon tote of chlorine, sodium hypochlorite looks like.
Mm-hmm.
And we can comprehend that only 11% of that probably is actual chlorine.
Mm-hmm.
The rest of it is just the medium that brings it, that delivers it to the flow.
Mm-hmm.
So, with that said, calculate the volume in gallons for a pipeline 14 inches in diameter and 2,156 feet in length. So a pipeline, what is a pipeline? What shape is it?
Cylinder.
It's a cylinder. It's like a long straw, right? So we know we're dealing with something cylindrical. Now that's a ground storage tank, and a pipeline, which is much more like a straw, right? And we're gonna lay this thing on the ground. It's 2,156 feet in length. Now, I can use 0.785 times the diameter times the diameter, or I can use pi times the radius squared. That's 3.14 times the radius times the radius. I like to use my 0.785, so I want volume, and we're going to put it in gallons, equals 0.785 times, it's 14 inches in diameter. And the length is 2,156 feet in length. I've got two different units of measure, inches and feet. Now, if I want to get gallons, I can't use inches. I need to convert inches to feet. How am I going to do that? Well, I'm going to take 14 inches and divide it by 12 inch per foot, right? So when I say inch like this, it's the same as saying inch over 1. It's the same thing. So I have 14 inch over 1 divided by, there's 12 inches to a foot, 12 inch to a foot. So what I'm doing here is I'm going to cross cancel and eliminate the inch, and I'm left with feet. 14 divided by 12 is?
1.16 or 1.2.
We'll call it 1.16 feet over 1. Okay? So let's take that. The pipeline is 14 inches in diameter. So I'm going to write diameter
Times diameter.
is 1.16 feet over 1. I'm going to multiply it by the diameter again. 1.16 feet over 1. Does that get me to gallons?
Not yet.
Not even close. I need length in there. I need volume, so I need the length in there. So the length
2,156 feet over 1. We all know what a cylinder looks like and a straw. I'm gonna get rid of this. How am I gonna get to gallons from here, Brian?
7.48 is your constant to get to gallons.
So what Brian is saying is there are 7.48 gallons of water per,
Cubic feet.
there's, whoop, shit, I wrote that the wrong way, didn't I?
It's supposed to be just per foot, right?
No. It's gallons per cubic foot. There are 7.48
Flip 'em.
gallons per cubic foot.
Yes.
It's one of those constants that every operator should know.
7.48.
There are 7.48 gallons for every cubic foot of water. That means if I have a cube, 1 foot in length by 1 foot in width by 1 foot in height, I have a perfect 1 square foot, 1 square foot cube, and I fill it to the brim with water, it's gonna be 7.48 gallons each and every time. That's a constant that never changes. It's the truth. It's reality. Now, the volume, I'm looking for volume in gallons. That's the unit of measure I want to get. I can't have feet. I can't have cubic feet. But what I can do is say, I'm multiplying straight across. I've got foot over the division line here, here, and here. I can cross cancel these out because I have cubic foot below the division line here. I'm left with gallons, which happens to be the unit of measure I'm looking for. Everybody agree with that?
Agree.
All right, somebody multiply 0.785 times 1.16 times 1.16 times 2,156 times 7.48.
You get 17,034. 0.75 if you want to put that in there, but yeah.
I just heard you mumble 17,000 what?
17,034.
0.34 what?
Gallons.
Gallons. Please get in the habit of using the unit of measure
Yes.
so that you're thinking that way. Everybody agrees with that number? Edward?
Yes, sir.
Nice. That wraps up the grade 2 distribution math. This is in Arizona. All the information you're gonna see on all my videos corresponds with everywhere in the United States and around the world. We all study the same information, the same subject matter. Some of us use meters and those other units of measure. In the United States, we're different than everybody else. We use feet, we use gallons, we use
Inches.
inches, yeah, so, but it all translates to the same thing. We treat wastewater in the United States just like they did back in London, just like they do across the ocean in India, in Europe, in other parts of the world. We use the same technology. It's the same subject matter. It's the same equipment. The best pumps we have are flight pumps. That's why in the job that I do, where we run the entire conveyance system, water and wastewater, we have centrifugal pumps at booster pump stations that moves the water to the customer through water mains and distribution mains and transmission mains. Once the customer uses the water and it goes down the drain, it runs through a network of gravity sewers that takes, in very many cases here where we are, to a lift station. And that lift station has submersible centrifugal pumps inside that lift station that we use to move that water to a wastewater treatment plant. And in the 38 now, we got rid of a few lift stations. We've got more coming online soon. By the end of the year, we'll have 38 lift stations. And each lift station has 2 pumps. And each lift station has a critical spare pump. And the very best pumps out there in the industry, in my opinion, they're flight pumps. And almost all my lift stations have them. Every new lift station coming online has flight pumps as the equipment.
and flight pumps are made in Sweden. A lot of the stuff that we do, a lot of the equipment a lot of the stuff that we do was not thought of or dreamed of in the United States. It was done in Europe, in England, in India, in other parts of the world. And that technology came here to the New World. A lot of the equipment we use, a lot of the parts that we use come from other parts of the world. Sweden, Germany. We're working with a group right now that's looking for leak detection in our water mains.
Yeah, that's the.
And they come from England. So this is stuff that every water operator, every wastewater operator around the world studies the same information that's available in all these videos. So it doesn't matter what exam, what certification you're going for. Watch all the videos you can that makes sense to you. Thanks for your time. Appreciate it.
Great class.